Fantastic. Right. So now we're going to hand over to Jennifer Swenson, who's going to talk to us about identifying settlements in agricultural landscapes. Thank you, Jennifer. Over to you.
Thanks for having me. I'm from William and Mary University in Virginia, public university, and fun fact is that it was established by royal charter in 1693 from you guys. But it's we're like twice as old as Exeter, but we're not quite as old as Cambridge. So anyway, great to be here. This is a project that I've been working on, or that I've been thinking about doing for quite a while. I thought it was going to be a great application for a CNN. It turns out it is. But it's something that so we have results, but there's also a lot more scaling up and exploration that I'd like to do after this. So this is a satellite image. This is Google Maps or Google Earth of the lowlands of Bolivia. Just a little piece of it. You can see it's kind of wild and crazy. There's all sorts of different shapes. Bolivia has undergone waves of government-supported land conversion and expansion, various economic actors, the Jesuits were there, etc. There's been just waves and waves to create this like a pretty crazy matrix. Of the deforestation areas I've seen in the globe, Bolivia is probably one of the messiest in terms of shapes and sizes, and just the patterns are really interesting. So, of course, we can map cropland. The World Cover Map, among others, maps this at 10 meters. We could also, if everything is cropland except for the forest patches in there. We could also map maybe, crop type if we got more seasonal information, like soybeans, etc. So like, here's just some examples of, maybe these are soybean patches. You can see that some are larger than others. Maybe the one in the center is industrial, and then maybe there's like a couple small dots in there that might be small family farms. One thing that we haven't done very well across deforestation landscapes or agricultural landscapes are mapping like who is actually doing the deforestation, who are the actors, even though we can sometimes do the crops. So that is the goal of what I'm doing here. What we're doing is to actually identify a specific cultural group in remote sensing. So this is the Mennonites, and are you guys familiar with Mennonites? The Amish, the horses and buggies, like in Pennsylvania in the U.S. These are a different sect related to the Amish. They're pacifists. They live in very isolated communities, and they are expanding. And they have been expanding for 300 years. This is information from an article called Pious Pioneers, as well as these are some drawings of the Mennonite settlements. This is Russia, this is probably too small, in 1874. And you can see there's this very straight line path. There are homesteads along that main road, and then there's these vertical fields extending on either side. And so, they're very, culturally they're fascinating. I'm a landscape ecologist, but it's a really interesting story how they speak Low German. They live in the middle of all these countries in these areas. They are really cut off from the outside world, except economically. They sell their products. Fascinating. But I don't want to digress too much. There's approximately, they're farming about 1 million hectares right now in Bolivia. They're expanding in other places like Peru. So this is an aerial view of their colonies, very consistent. North-south, east-west main roads, and with these houses out from the main center, and then long fields that are not shown here. This is actually a photo of Peru, and so there's still it's a very new colony, so there's still some remnants of the forest there. But mostly in Bolivia, this is what they look like, if you can see that. So you've got this is 2 different colonies on the top, and then the start of 2 more on the bottom. And so this is an amazingly consistent pattern. And I kept seeing it, and I was like, oh, this is like CNN ideal. Because it is just this very distinct pattern amid all this other crazy agriculture. So, and there's a caveat here too that this is this is kind of a hot button issue right now because they're expanding, and they're expanding into areas of primary forest. They're really good at clearing primary forest and establishing very successful agricultural crops, as well as cattle. And so it's kind of a hot button issue right now in Peru. They're expanding pretty rapidly. There's this Monitoring Andes Amazon program, looks at high resolution imagery and focuses on things like gold mining and industrial expansion, but they also have, the Mennonites in their sites, and so you can see, this is primary forest. We are tearing, it's a lot of work to clear primary forest with low mechanization, and so they're doing amazing progress for 11 months or less here. So what we did is this is the Santa Cruz Department of Bolivia. You can see the area maps on the upper right, and so the CNN idea, we didn't get fancy. We grabbed ResNet 50, which is a neural network with 50 layers, 50 convolutional layers, and it's 10 years old this year. Who knew that ResNet 50 is already 10 years old? We use the pre-trained model, and then we let it fine-tune on all the layers. And then we had to think a little bit about sampling. So the blue that you see here, this was just dumb luck, is that someone, this article of Pious Pioneers, had actually hand digitized the colonies in all of Latin America. It's not perfect. It was done in 2020, so there's things that have changed. We use 2020 imagery here, but it was really a boon for us because that was our training. That was our presence right there. So we use them. Again, they're not all perfect, but we use them the way they were just to start out. And so that was really key. So for the non-Mennonite data, so we were interested in just classifying the Mennonite data, Mennonite presence colonies versus non. And so for the non-Mennonite, we ended up sampling, we used the world cover land ESA map, and just selected areas in the department that were at least 60% agriculture. And those are all unique image chips, so we use like a 512 by 512, which is kind of one of the standards, 2.4 kilometers on a side. And then we basically, they're all unique, so we actually made a grid that was 512 by 512 across the whole area. So there was no rotation or like resampling. And we ended up with, not a huge number, but apparently good enough. So 5,000 chips like that, and so we had fewer Mennonite chips, as you can see, 1,700, and then more non-Mennonite. And then we divided training versus testing 90 to 10%. And we got just for the 10%, we got a better, an even distribution of non-Mennonite and Mennonite using the inverse of the class frequency. And our imagery we chose was, we thought, oh, this is great. We're going to use the publicly available Planet NICP data set that now this spring costs $110 per user per month, promotion. So that's unfortunate. We thought we were, doing something good that could be used by everyone. We might try Sentinel too after this, but that's what we did. So here's our results: the testing data set and the training data set. You can see it was better than I thought it was going to be. We've got the typical. Actually, this was in Sunny's. Sunny gave us the calculations in his presentation, so I'm glad I didn't put them up here. There are, it's really pretty high for the testing data set. There's some false negatives, I think, in the recall, but we did, multiple runs of the testing data set that you can see down here in Monte Carlo. So in the end, it was, we were really pleased with the effect, or the success. And I think the key here is not just, we can identify Mennonite colonies versus everything else, but everything else was actually agriculture. So if we had, put in primary forest and, bare earth, it would have been even better. So this was actually a really successful run because what we were comparing it to was very similar, right? Except for those key patterns. And so then I wanted to know, well, what's actually making the CNN choose well or not so well? And so we started looking at image chips and seeing which ones were classified as correct versus not. And there were some issues, but not that many. But I'm still curious about it. So this was predicted non-Mennonite, but then the true label was Mennonite, and you can sort of see why that happened. So the big stripes on top are not a Mennonite community. I suspect they're actually, they might be cattle of the Mennonite community, but they're very different because the hedges between each field are much thicker. They don't have a road down the middle, and they don't have the buildings. And so this is another example of a true prediction. And you can see that it's mostly, it's doing really well with these sort of striped patterns. Yet there are those buildings like right on the edge that cue you in that it's probably going to be a Mennonite settlement. So those are just a couple. But the next step really is to uncover what's happening. And so being from the remote sensing community for years and sort of dealing with the CNNs and things like that on the side, I really wanted to see what is going on, what is making the CNN choose right or wrong. And the image chips is not really a very efficient way of doing that. But so what we're going to do next, which we don't have ready to show you today, is looking at sort of explainable AI. And so my collaborator does this. He's sort of pushing the boundaries of doing this with his students, looking at things like GradCam or ShapCam. And actually you can peel away I'm sure people have done this already, but you can peel away and look at the CNN layers to see what part of the image is actually cueing it. So is it those cardinal directions? Is it the striping? Is it those buildings? It's probably all of those, but we're running those now, but we don't have anything to show yet. So another thing that, just some thoughts to share is, and places where you want to go is, the image chips, they want RGB, and so we give it RGB. And I'm always like, why are we giving it NIR? Throw out the blue, or especially if you're working in areas of vegetation. Like this is all about really the vegetation patterns with some buildings. But the NIR is going to be even better, I suspect. So that's kind of the next thing I want to try and compare if NIR is better. We already have a model that works really well, but it's just sort of a thought to, you should be throwing NIR in there. That's my personal opinion. So again, the next step would be to scale this up. Potentially all of Latin America. They are sprinkled up and down all of Latin America. They started in Canada. Things might get harder when things get more arid because, again, it's the vegetation contrast that works really well. And then, again, trying Sentinel-2, since now we're kind of stuck with the 5-meter NICFI data set. And then expanding the time series. So this gets to that potentially more political and hot button issue of where the Mennonites have grown in the last 5 years. So that's kind of, because we have this model that works really well, that could be an idea to see where they've expanded. And maybe expanding this approach to other land uses. So like those big stripy things that we saw above the community, which I suspect are their cattle operations, could also be another class to look at. And that's it.
Thanks very much. Any questions from the audience? Yes, sir.
I was wondering if you had a chance to look at the SAR image for this application, because these kind of settlements are usually look very bright in the SAR image, and you can maybe discriminate easily using a image modeling approach. So
I think I'm sure the buildings would pop out, right? I guess I was really leaning towards being more of my comfort zone is multispectral, but I think SAR is pretty amazing. Would be that Sentinel-2 could probably pick these patterns up as well. But yeah, I think SAR would also, depending on how high those hedges are between the field, that would be a bright spot as well. So that could be. And this is an area of a lot of cloudiness too. So if you actually wanted to track faster, up to date, then maybe SAR. Yeah, I haven't looked. Maybe I should. Thanks.
question. I mean, actually, I had a similar question to Yasser, but I was going to sort of say nighttime lights as well, because we've seen that used in some of the other talks, and it might at least highlight the
I
collection
think
of
the
hazards.
resolution, isn't it still like 100 meters? Because they're out, like, sometimes they're out in the middle of nowhere, sometimes they don't have electricity,
Okay.
because each sect has sort of their own defined rules of what they do, so sometimes they can have lanterns, but not electricity, or sometimes they can have electricity to support the agri, they all are a little different, so, but yeah,
Okay, so my other question was a sort of broader one about, once, it was a bit like Andy's other question, once you've got the information, who is it for, and what are the kind of social or environmental justice implications of this work?
yeah, so we are like this, we're going to just publish this as a short paper, a short like methods paper, and we're making it very, look, this is a bunch of different agricultural patterns and we can pick this one out, because scaling it up and then targeting this cultural group, I mean, they have been targeted. If you just Google like Mennonites and deforestation, you will find all sorts of news articles. So like that next step, we're kind of like, do we need to work with like an anthropologist, or, I mean, because it's a much, they're like pacifists, and we're also feeling like we don't want to just call them all out and say, look what they're doing. I mean, they're getting called out already, but yeah, I don't know. That's a difficult next step. Scaling it up, for sure.
Okay, any further questions?
One hand there. That's kind of.
Yes, sorry, you. Sorry, I didn't see that.
Thank you very much. It was really interesting. I was just wondering if you'd come across the Earth genome work that's been done for detecting gold mining in the Amazon. It just seemed quite familiar, like in a lot of ways. So I was wondering whether adopting an approach using a foundational model and fine-tuning it, if you're intending to scale this at a continental scale, that might potentially be.
And we might, because again, like this is, I kind of think, like originally I sort of defined this area because I knew it was going to be kind of the hardest, because it's such a mess around it. Like the colonies in Peru they're in like primary forest, and so there's just this little square patch, of the road and everything in the primary forest. So, but yeah, it could get a lot messier again. Like if also they are in the Chaco, which is in Paraguay, down below, and that is like super dry, and so we haven't tried doing that yet either. So it might have to be a whole different approach if we expand. So.
Okay, thank you very much, Jennifer.